Welcome back to the second part of the higher order derivatives homework video guide. And for this video, we're going to start off with example number 3, question number 1. And we're given this function here, and my goal is to find its second derivative. Okay, so this means second derivative. Okay, so let's go ahead and find the second derivative by taking the finding the first derivative. And for this question, we have to use the product rule to get started because this is a product of two functions, and the product rule states that I need to take the derivative of this first function, which is 1, the derivative of x is 1, times the second function, which is f of x squared. And then the product rule states that I need a plus, and let me just erase this now. And I can write the first term, which is x, times the derivative of the second term, which is f of x squared. So that would be f prime of x squared times 2x. All right, so that's my first derivative. Before I go on to my second derivative, I will go ahead and just clean up the first derivative. So this is f of x squared plus, and then for the second term here, I can just kind of multiply those two guys. 2x times x is 2x squared times f prime of x squared. All right, so that's my complete first derivative, and I can now move on to my second derivative because my first derivative has been simplified. All right, so let's take a look at this expression right here. How do I find the derivative of that? Well, the derivative of f is f prime of x squared, and then the chain rule states that I need to take the derivative of the inside guy, which is 2x, plus. Now I have a product of two functions again, so I need to use the product rule one more time. So the derivative of 2x squared would be 4x times f prime of x squared plus the first term, which is 2x squared, times the derivative of the second term, and the derivative of f prime is f double prime of x squared, and then the chain rule states that I need to take the derivative of the inside guy, which is 2x. And that is my final answer. Okay, I'm just going to switch to the next document here. All right, so this is example. We're now moving on to example 3, question number 2. And in this particular problem, we're given certain values to start off the problem here. And our goal is to find the second derivative when x equals to 2. So we're finding the value of the second derivative when x equals to 2. And this is my function right here, f of x equals to f of x all squared. So if I take the derivative, or the first derivative, I can use the power rule, and the power rule states that this 2 comes out in front, so that would be 2 times f of x. And then the chain rule states that I need to take the derivative of the inside guy, and the derivative of the inside guy is f prime of x. So that's my first derivative, and then I can follow that up by taking my second derivative. And for my second derivative, I'm basically using a product rule. So this is like the first term, and this is the second term. So I need to take the derivative of the first term times the second term plus the first term times the derivative of the second term. So the derivative of this expression right here, which is the first term, is going to be 2 times f prime of x. So 2 times f prime of x. And then I just copy out the second term, which is f prime of x. And then the product rule states that I need to add the first term, which is 2f of x, times the derivative of the second term. Now, since this is f prime of x, the derivative of that is f double prime of x. All right, so that's my second derivative using the product rule. And then the question is asking for what is the value of the second derivative when x equals to 2. So anytime you see an x now, these x's will now change. They'll be substituted with the value of 2, because I'm trying to find the value of the derivative when x equals to 2. So if I substitute 2 into all the x's, I get 2 times f prime of 2 times f prime of 2 plus 2 times f of 2 times f double prime of 2. Now for all these values, let me just kind of erase these beginning values here. These values that I'm highlighting here, I mean, essentially you will get those from the original problem. You need to go back to the original problem and find those values. Let's start with f prime of 2. Well, f prime of 2 it has a value of negative 2, right? So if I just follow this up to there, I can now write 2 times negative 2 times negative 2, and then plus, well, what's f of 2? Well, f of 2 is, if I follow the colors back to the original problem, f of 2 is negative 1, so now I have 2 times negative 1, and f double prime of 2 is this guy over here, which is going to be 3. So this will be 3. All right, now we can just multiply out the numbers here. 2 times negative 2 is negative 4. Negative 4 times negative 2 is going to be it's going to be 8, positive 8. And then this expression right here, 2 times 3 times negative 1 is going to be negative 6. So 8 minus 6 is going to be 2. So 2 is my final answer for that problem. Okay, let's move on to question number 3. For question number 3, I need to go to my other document here. So here's question number 3. And I need to find, it's very similar to question number 2, where I need to find the value of the second derivative at x equals to 1. So basically I'm asking for what is the value of f double prime of 1. What is that value equal to? That's what this expression, that notation means. Okay, so my my function is f of x cubed. So if I rewrite this on the side here, that's the same thing as y equals to f of x cubed. And then we can now take its first derivative. Well, the derivative of f is going to be f prime of x cubed. And then the chain rule states that I need to take the derivative of the inside guy, which is going to be 3x squared. So that's my first derivative. And now I can take my second derivative, and the derivative of f prime is going to be f double prime of x cubed. And then the chain rule states that I need to take the derivative of the inside guy, which is 3x squared. And then I multiply that with the this second term here, which is just 3x squared. All right, so essentially I'm just doing a product rule, right? So this is, if I want to find the second derivative, you just use the product rule. And the product rule states that I need to add now the first term, which was this guy, which is f prime of x cubed, times the derivative of this second term. So the derivative of 3x squared is going to be 6x. Okay, so that's my second derivative right there. And remember, the question was, what is f double prime of 1? So anytime you see an x now, these x's will now change to a value of 1. So this will be f double prime of, well, 1 cubed. Sorry, 1 cubed is just 1. And 3 times 1 squared is going to be 3. And 3 times 1 squared is also going to be 3. Plus, if I plug a 1 here, that will be f prime of 1 times 6 times 1 is just 6. Okay, let's go ahead and finish off the problem here by substituting the values here. So f double prime of 1, if I go back to the original problem, f double prime of 1 is going to be negative 2. So this has a value of negative 2. And then if I just do 3 times 3, that's going to be 9. Plus, f prime of 1, if I go back to the original question, f prime of 1 has a value of 3. So this will be 3 times 6. So this will be a negative 18 plus positive 18. That gives me a final answer of 0. Okay, let's move on to the last question in this homework guide. Example number 4, question number 1. This might be one of the longer problems in the homework. So I need to find the value of the second derivative when x equals to 1 and when y equals to 1. Alright, so I need to take the second derivative, and then anytime I see an x and a y, I substitute the values of 1 and 1, and then I find the numerical value. Alright, if this is my expression for this problem, you should be thinking about implicit derivatives. Alright, so one of the reasons why I have a value for x and y compared to the previous problems that we didn't have a y value, but In this question we do because we're taking the derivative of an implicit function here. All right, so let's do this. The derivative of y squared is going to be 2y times, now this may be a bit tricky, but the inside guy is y, so it'll be 2y times y prime, plus, all right, then I have to use the product rule on I need to use the product rule on x times y, so the derivative of the first term is 1, times the second term, which is y, plus the first term, which is x, and times the derivative of the second term, which is y prime, and the derivative of 2 is just 0. Okay, so just cleaning this up here, this would be a 2y times y prime plus y plus x y prime equals to 0. And then the goal is you should try to isolate the y primes. And this term right here in blue, we should move that to the other side. So now I have negative y on the other side, so that term's gone. And then I should go ahead and factor out the y primes here and here. So if I factor out the y primes, I get y prime bracket 2y plus x. And then if I isolate for y prime, I get negative y all over 2y plus x. Okay, so this is the expression for the first derivative. Now, because I've done these problems in advance, what you should be thinking about is finding the numerical value of the first derivative. So these values of x and y, so the values right here, we should plug those values into our first derivative and get the numerical value of y prime. This will help us in our second derivative. So this would be negative. Well, the value of y is going to be 1. Divided by 2 times 1 plus, well, the value of x is just 1. And if I evaluate this, this will be negative 1 over 3. Okay, so what we've just found there is y prime has a value of negative 1 over 3. And we're going to be using that in the second part of this problem here, because in the second part of this problem, I need to go ahead and take the second derivative. So I need to take the derivative of this guy to get y double prime, right? So if I go ahead and just move the problem forward now, y double prime, I need to use the quotient rule now. And the quotient rule states that you take the denominator here, which is 2y plus x, times the numerator. Now, the derivative of the numerator here, negative y, is just going to be negative y prime. And then I'll close the bracket. And then using the quotient rule, I need a minus sign, and then I would times it by the numerator, and then I would times it by the derivative of the denominator, which is 2y prime plus 1, all over the bottom all squared. Okay, so that is my second derivative, and what we have to do now is anytime I see a y, I'm going to replace those y's with a 1, because remember, y equals to 1 and x also equals to 1 from the start of the problem there. And anytime I see an x, I'm going to replace that with a 1. And anytime I see a y prime, that's going to be replaced with the negative 1/3. All right, so now this game is, in order to kind of finish this problem, it's all about substituting the right values into your second derivative. So this is 2 times, well, the value of y is 1, plus the value of x here is going to be 1. Close that bracket off. And the value of negative y prime is going to be positive 1/3, right? So let me just erase that and just write down 1/3, because there's 2 negative signs. Minus, this will be negative 1, close the bracket, this will be 2 times negative 1/3 plus 1, close that bracket, all over, the bottom is going to be, well, these will be, sorry, there's a value of 1 here and 1 there, so 2 plus 1 is going to be 3, so the bottom is just going to be 3 to the power of 2. Okay, so we've substituted the values in there correctly. We just need to simplify everything now. So over here in green, that's going to have a value of 3. 3 times 1/3 minus, this will be negative 1 times Now this expression right here, we have to do a little bit of work there. That's negative 2/3 plus 1. And negative 2/3 plus 1 is the same thing as negative 2/3 plus 3 over 3, which is going to be 1/3. So this will be 1/3 right there. And then I will close the bracket here. All divided by 9, I believe. So 3 to the power 2 is 9. All right, almost done here. 3 times a third is going to be 1. Over here I have a minus and a minus, so a minus and a minus will be plus. So 1 plus 1/3 divided by 9. And if I continue here, 1 plus 1/3 is going to be 4/3 all over 9. And then you can take your 3 and your 9 and multiply those guys, and your final answer should be 4 over 27. All right, so that's the answer for that particular question, and that will conclude this video homework guide for higher order derivatives.